Good morning, parents. I am writing today. I'm not writing, I'm making a video. I'm talking to you today, asking for help with teaching math. I know that when we were kids, we learned to do addition, two-digit addition, by simply lining them up in their tens and ones, adding the ones, and then adding the tens. Now, with the new Common Core, there is a large focus on understanding why math works. And the algorithm doesn't actually teach us or teach the students why it works. It's just something that they do, and they don't understand what they're doing. So it leads to a lot of students making mistakes. It leads to a lot of students forgetting things, and it doesn't stick as well because there's no understanding behind it. So what I'd like you to try to do with your students is have them show their thinking. This algorithm, it doesn't show any thinking. It shows that they can add in columns, but if you ask them why you had to set it up that way, most of them won't know that they're adding the tens and then they're adding the ones. They're just starting at the right and working their way left. So I would love it if we could try other ways. So one way that students could show their thinking is on a number line. An open number line, they put the numbers on. So if you have 30 and you're adding 45, they're going to show the jumps they do. Some students could jump all the way and show 40 here. Other students need to do smaller jumps to get there, so they maybe count on by 10. So they're going to think about 4 as 4 tens. They're going to think 10, 20, 30, 40. Put 10 in each one of those. This is showing us that they can decompose a number, and it's showing us that they understand that the 4 in 45 doesn't mean 4, it means 40. Then they do another jump, which is 5. Down here, they would show 30, 40, 50, 60, 70 plus 5 more is 75. This is showing us that they know that these numbers mean something. Okay, another way they could do it is by drawing a picture. We use base 10 blocks, which just those yellow cubes. There's little cubes. There's some that are stuck together like there's 10 cubes together, and then we have some that are stuck together like there's 100. And the kids know how to draw those pictures to represent those cubes. So a lot of them have transferred, instead of using the cubes, they just draw pictures to show that. So I can make 10, 20, 30, and then over here I can do 10, 20, 30, 40, 41, 42, 43, 44, 45. And then what they do is they count the different tens together. So again, this is showing us that they can decompose the number, that they know that 45 has 4 tens and 5 ones. Then when they count 10, 20, 30, 40, 50, 60, 70, 71, 72, 73, 74, 75. And if they don't need to count those, if they can just look at that and say 3 and 4 is 7, and then 5 more, or 3 and 4 is 7, but really that's 70, and then 5 more is 75, that's fine too. They need to show us some visual representation of what they're thinking. Could be the number line, could be this. I saw a couple other students do 3 and 4 is 7, so 30 plus 40, 40 is 70, and then 5 more, 70 plus 5 equals 75. And I know that I know that some of us are thinking, but doing the algorithm and doing the traditional way is so much faster. But right now in second grade, we're not worried about how efficient they are. We are worried about them understanding what they're doing. Because I can tell you, when I taught fourth grade, I had a lot of students who could do this problem, but they could not tell me what that one on top meant or why they were doing it. They just knew you were supposed to. So we want students to eventually be able to say, I know that I'm moving this one on top because 6 plus 8 is 14, and that's the 10 from 14, and I can decompose that and separate it. So eventually, they'll move to the algorithm. They don't need to have that mastered until fourth grade. So in second grade, we are really working on the understanding behind the math. So I know that because it's the way we learned, that's the way we want to do it. But if there's any way you could have them try some of these other options, and really if there's any other way that they can show it, that would be great. But doing the algorithm doesn't show their thinking to me, and I don't understand if they get it or not. We're trying to take something that's done in their head and put it onto paper. Eventually, they'll just be doing it in their head, and that's fine. It's another way for them to explain what they're thinking. So I do have an article that I'm posting with this that explains the same thing I was just saying. It's a pretty quick read, someone's blog post. So if you have a chance to read it, that would be great. If you have any questions, let me know, and hopefully this helps. Thanks so much.